Hey guys, so in the previous video we were talking about the chemical reaction of the hydrocarbons. We know that alkanes and alkenes are not exactly same chemically, because alkanes have no carbon-carbon double bond, alkenes have one or more carbon-to-carbon double bond. But combustion reaction was one thing that is common in both the hydrocarbon series, and combustion is essentially the reaction of a substance with oxygen in the air to give oxides. Now all the elements within a substance, when they are combusting, they give oxides while reacting with oxygen atoms. So hydrocarbon has carbon and hydrogen atoms. So carbon atoms give carbon dioxide and hydrogen atoms give water molecules when they react with oxygen atoms. Combustion could be two types. It could be complete or incomplete. In complete combustion, the element or the substance reacts with excess oxygen, unlimited oxygen, and all the carbon atoms get enough oxygen to make carbon dioxide, and hydrogen gets water molecules. In incomplete combustion, there is a limited supply of air or say oxygen. So what happens is that some of the carbon dioxide and water molecules are made, but other carbon atoms make carbon monoxide, and there are few carbon atoms which make only pure carbon. They do not react at all, and that pure carbon is also known as soot. In today's video, we're going to be talking about how to write combustion equations. We're going to be talking about complete combustion equations. The idea is to understand how many moles of one thing reacts with how many moles of the other thing. So for example, if we have methane molecule, which is first member of the alkane series, and it reacts with oxygen, so the question is how many carbon dioxide molecules and how many water molecules will be made. One thing is very clear, that methane has one carbon atom. So this one carbon atom will give you only one carbon dioxide. So you get one carbon dioxide. You can also see there are four hydrogen atoms. So there are four hydrogen atoms, and you know in water molecules there's already a 2 over here. So 4 hydrogen atoms can give 2 water molecules. So 4 hydrogen atoms will give 2 water molecules. It is all about balancing because 2 2s are 4. So 4 hydrogen atoms give 2 water molecules. Now it's a matter of counting the number of oxygen, because one carbon gave 1 carbon dioxide and 4 hydrogen atoms gave 2 times 2 is 4 hydrogen atoms in the water molecule. The question is how many oxygen atoms are used up. So you can see 2 oxygen atoms are here and 2 ones are 2. So 2 atoms in the water molecule. There are 2 oxygen atoms in the water, 2 in the carbon dioxide, so it's a 4. You need to divide that 4 by a 2 to give 2 oxygen molecules, because there's already a 2 over here for the diatomic nature. So no matter how many oxygen atoms you get in the right hand side, just divide that number by 2 and you will get the amount of oxygen on the left hand side. We will try one more equation, so that's not the end guys. Let's try one more. C2H6. I'll put it a little lower so that we have enough space to play with the atoms. We know it's going to react with oxygen. We know it gives me carbon dioxide, but how many carbon dioxide? So you can see there are 2 carbon atoms over here. So I should be getting 2 carbon dioxide molecules, because each carbon gives me 1 carbon dioxide. So there are 2 carbon dioxide. How many hydrogen atoms are here? There are 6. So you get 3 water molecules, because 2 3s are 6. So 6 hydrogen atoms give you 3 water molecules. It's a question of how many oxygen atoms will be there. So let's count it. 2 2s are 4, 2 2s are 4, and 3 1s are 3. So 4 plus 3 is 7. 7 oxygen atoms are used. You just put a 7 divided by 2, because oxygen is already a diatomic molecule. So simply you got your answer. Let's try one more. For example, C3H8, that is propane. It's a 3 carbon alkane. Now when propane reacts with oxygen, you again get carbon dioxide and water. We are talking about complete combustion, but how many carbon dioxides? So you know one thing is for sure, that 3 carbon atoms can give you 3 carbon dioxide molecules. So you get 3 carbon dioxide. Because you know each carbon atom is present in 1 carbon dioxide. There's 1 carbon in 1 carbon dioxide. So 3 carbon atoms are enough to give you 3 carbon dioxide molecules. What about the water molecules? So there are essentially 8 hydrogen atoms. 8 hydrogen atoms can give us 4 water molecules, because 2 4s are 8. So 8 hydrogen atoms will give us 4 water molecules. We are done with that. Now let's count the oxygen. So 3 2s are 6 and 4 1s are 4. 6 plus 4 is equals to 10. You have used 10 oxygen atoms in total. So 10 divided by 2 is 5. So you need 5 oxygen diatomic molecules to give you 3 carbon dioxides and 4 water molecules. Let's try one more. For example, you have C4H10, which is butane, a 4 carbon alkane. It reacts with oxygen. You know this already. It's going to give you carbon dioxide and water, so I'm done with that. But how many carbon dioxides? So 4 carbons can give you 4 carbon dioxides. Each carbon gives 1 carbon dioxide, right? So you get 4 carbon dioxides. Okay. What about the water molecules? You have 10 hydrogen atoms, which can give you 5 water molecules. Each water molecule has 2 hydrogen atoms. So 10 hydrogen atoms can be fit into 5 water molecules. So 5 water molecules, because you know 5 2s are 10, so hydrogen is already there. 10 hydrogens can give you 5 water molecules. Let's count the oxygens. So we know 4 2s are 8 and 5 1s are 5. So 8 plus 5 is 13. You have used 13 oxygen atoms. But oxygen is a diatomic molecule, you know. So it should be 13 divided by 2. It is totally okay to write with a fraction. So you can write 13 divided by 2 as a fraction. That is totally acceptable. So remember one thing. Within an alkane or whatever hydrocarbon, 1 carbon is equals to 1 carbon dioxide. No matter how many hydrogens are there, 2 hydrogens is equals to 1 water molecule. So the number of carbon dioxide is equals to the number of carbons within the hydrocarbon, but water molecule should be half the hydrogen. And when you're done, you just count the number of oxygen and divide it by 2. So you can say carbon is equals to carbon dioxide, but water is equals to half the hydrogen. And then you just count the number of oxygen and just divide it by 2. Before ending the video, let's try one more to recall everything. Let's suppose I'm talking about pentane. C5H12, it's a 5 carbon alkane. And right now we are talking about reacting it with oxygen. Let me check how many carbons are here. So I know there are 5 carbons because you know the name is pentane. Okay. 5 carbons in the pentane molecule can give me 5 carbon dioxide. I'm happy with that. Okay, that's 5 carbon dioxide molecules I'm getting over here. Apart from that, I have 12 hydrogen atoms. So 12 hydrogen atoms will give me half the water molecule, which is 6. So I will get only 6 water molecules. 12 hydrogens give me 6 water molecules. Let's count the number of oxygens over here, guys. 5 2s are 10 and 6 1s are 6. 6 plus 10 is 16. I need 16 oxygen atoms. But when I'm talking about diatomic molecule, I get 8 oxygen molecules, because 16 atoms can be present in 8 molecules. And I got 5 carbon dioxide molecules and 6 water molecules. All you're doing is you're just having, for example, now I'll make this very clear. Let's suppose this is ethane with its 2 carbon atoms and 6 hydrogen atoms. 2 carbon atoms could make only 2 carbon dioxide, so you get 1 carbon dioxide, you get another carbon dioxide over here with the oxygen atoms. So these are the oxygen atoms. So you get 2 carbon dioxides. The red dots are the hydrogen atoms. So you get 1, 2, 3, 4, 5, 6. 6 hydrogen atoms can give you 3 water molecules. You get 3 water molecules. So these are your ethane molecule. It is giving you 2 carbon dioxide molecules and it is giving you 3 water molecules. And this is essentially what we got over here. And to get this many oxygen atoms, you needed 7 by 2 oxygen molecules. So just remember this fact, how we create combustion equations. In the coming video, we'll be talking more about it, but then we'll be jumping on the substitution reaction. So guys, remember, the number of carbon is equal to the number of carbon dioxide. The number of hydrogen will be divided by 2 to give you the water. And then you count the oxygen, and whatever the number of oxygen is there, you just divide it by 2 to get the oxygen required in the equation, and that is a pure balancing. I hope you guys are going to practice it a lot. Thank you guys. Stay there.